Hey everyone, this is going to be a quick video on the relationship between fixed cost, unit cost, and price, and how that affects total cost and revenue and profit. And we're going to be using Excel for this. So let's say we have a particular fixed cost, a particular unit cost, and let's make those, let's say fixed cost is 50 and unit cost is 4. And then we'll create a table for how many units are produced or how many times a service is performed and the total cost. So we'll start with 0 and let's go by tens. No, let's go by fives actually. Okay, so we're going from 0 to 40 units. And our total cost, it's equal to our unit cost times the number of units plus the fixed cost. Now, as we copy and paste this formula, we want unit cost to remain referencing the same cell, and we want fixed costs to be referencing the same cell. So we'll add these dollar signs here. And copy and pasting that formula, we have total cost, how that depends on the number of units produced. You'll notice that if we produce 0 units, our total cost is 50 because all we've paid is the fixed cost. If we produce 5 units, our total cost is 70. It increases by 20 because we have 5 units and each of those units costs $4 to produce. So that's an increase of 20. If we want to create another 5 units, so here we go from 70 to 90, that's another $20. Another 5 units, 10 to 15, 90 to 110. That's another $20. To look at it more simply, we can just look at how much the cost increases if we increase the units by 1 on this chart. And you see with each additional unit produced, the total cost increases by 4. So we can graph this. Just a scatter plot, and I'll have a straight line connecting it, and that's what our relationship looks like. Okay, so you see at 0 we have a cost of 50, and the total cost increases by 4 every time our number of units increases by 1. Okay. I'm just going to move this over a little bit. Okay, now I'm going to change the axes just so it's fixed. We'll keep the minimum 0. We'll make the maximum 100. And on the horizontal axis, we'll keep the minimum 0 and we will make the maximum 10. Okay. So if I change the fixed cost from 50 to say 25, you see that line drops down. The slope remains the same because the unit cost is the same. Right? We're still going up by 4 each time we produce another unit. The total cost goes up by 4, but the fixed cost is different. Our starting point, that base value of 25, is lower than the base value of 50, so that's why our line dropped. If I turn it back to 50, it goes back up. Okay? Now, if I increase that unit cost from 4 to say 10, well, you notice the starting point is the same, but the line is now steeper. Okay, our total cost grows faster because with each additional unit, we're paying an extra 10 rather than an extra 4. And again, if I change the fixed cost from 50 to say 20, the whole line drops, but the slope remains the same. Okay, our fixed cost is only 20, so we have a lower starting point, but how much more we have to pay with each additional unit is now 10 instead of 4. And we see that reflected on our table here. Right? At 0, we still have to pay that fixed cost of $20, and then it's an additional $10 per unit. Now, we're going to add another piece of information here, which is price. How much do we sell this for? Okay. And we're going to plot the price as well. So, let's say we sell it for $15. Well, our revenue is going to equal our price multiplied by how many we've sold. Right? Revenue is how much money comes in. And of course, as we copy and paste this formula, we put dollar signs here because we want that coordinate of price to remain the same. These dollar signs have nothing to do with the fact that we're talking about money. So, we have our revenue. If we sell 0, we make 0. If we sell 1, we make 15 because the price is 15. Okay. If we sell 2, we make 30. If we sell 3, we've brought in 45, and so on. Each time it increases by 15. And we can plot this. That's our name. These are our X values, and our Y values are revenue. Okay, so this orange line, this is revenue. Okay, this is how much money is brought in. Now notice the revenue line is steeper because our price is 15. For every additional unit, revenue brings in an additional $15. Whereas our blue line is not as steep because the unit cost is 10. For each additional unit, we're spending an extra 10, not an extra 15. So it's not as steep of a line. So even though our fixed cost is 20, so our total cost starts higher than our line representing revenue, eventually that line representing revenue catches up and intersects at 4. Intersects at 4. Okay? And so that 4 is a very specific value. Look what happens at 4. Okay? Once we have 4 units sold, our total cost is equal to 60, and our revenue is also equal to 60. Our revenue is equal to our total cost. That is the break-even point. That's the break-even point. It's how much do we need to sell so that we're not losing anything, so that our profit is equal to 0. And if you remember profit, that is equal to the revenue minus the total cost. So if we don't sell any, we're only paying our fixed cost, we're not bringing in any money, we've only spent that $20. Our profit is negative 20. If we sell 1, well, in total we spent 30, 20 of fixed cost plus another 10 unit cost, but we brought in 15. So our profit is negative 15, right? We spent 30, we brought in 15, we lost $15. But because revenue is increasing by 15 each time, whereas total cost is increasing by 10 each time, eventually the profit line will catch up, and eventually our profit becomes 0. That's breaking even. After that, our revenue is now bigger than our total cost, and so our profit becomes positive. Okay, profit is literally, the orange curve minus the blue curve. When the blue curve is higher, you have a small number minus a bigger number. You end up with a negative value. When the orange curve is higher, you have a larger number minus a smaller number. And the result is a positive number. So profit is positive. And we can plot profit. And to do that, I'm actually going to increase this scale again. Instead of 0, we will allow negative 40. Okay. So, we're going to plot profit. Our x values are the same, and our y values are here. So that gray curve, that's our profit curve. And if you look, what happens at 4 at our break-even point? Well, that's when profit is 0. That's why it's called the break-even point. You've brought in as much as you've spent. Your profit is 0. After that, your profit becomes positive. Now what happens if our price is higher? If instead of selling it for 15, we're selling it for 20? Look at that. It doesn't change the blue curve. Let me show you again. 15 versus a price of 20. The blue curve stays the same. Our costs stay the same. But this orange curve is now steeper, right? Our revenue is steeper because we're making 20 instead of 15 with every sale. And the profit curve also became steeper, right? Because the profit curve is the orange minus the blue, right? And now our break-even point is 2 instead of 4. There it is. Because we're selling each item for more, we make a profit sooner. Our break-even point becomes earlier. Now, that doesn't have to be done with increasing the price. It can also be done with decreasing the unit cost. If instead of each additional unit costing us an additional 10, what if it costs us an additional 5? Look what happens there. Let me show you again. 10 and 5. This time the price curve remains the same, but the cost curve drops. The cost curve is not as steep. We're not spending as much extra funds for creating every additional unit. So our cost curve drops. And then when we're subtracting our cost curve from our revenue curve, we get a steeper profit curve because we're subtracting smaller values. Now in all this time, that profit curve, it was still at negative 20. And our cost curve was still at positive 20 because that's the fixed cost. Even if we don't sell anything, even if we don't produce a single unit, we still have that fixed cost to pay. But we can change that fixed cost. Let's say instead of 20, we make it 40. Well, look what happens now. Okay, I'm going to show you again. 20, 40. The orange curve stayed the same. The blue curve, cost, is the same slope, but it's now higher up. So our profit curve became lower. Right? Our cost is increased, our profit is now lower. Our break-even point is now further down. It's now at 8. Let me increase the scale here so you can see that better. Let's make it to 150. Okay, and let me just add another line here. So just a second. There we go. Okay, so you can see that intersection, right? So now our break-even point is later on. It's 8, okay, because we have a greater fixed cost to overcome, right? So our break-even point shifted to be further back as well, right? Because our fixed cost increased. Remember before it was 20, right? Now we can also decrease that fixed cost to say 15, okay? And now we have our break-even point earlier on at 3, and our profit curve is also higher up. Okay? Now, that break-even point can also be pushed back by increasing the unit cost to say 20. Right? Now look what happens. This blue line is steeper than the orange line, which means they will never intersect. Right? Our unit cost is greater than our price. If for every time you perform the service, for every item that you produce to sell, making it costs more than selling it, you can never break even. And what you see is your profit line is actually dropping. It's now negative, okay? Because your price is lower than your cost. Because your price is lower than your cost. So, that's the relationship between price, fixed cost, unit cost, and how that affects your total cost, your revenue, and your profit, how that depends on the number of units sold.